Okay, so how often are new blocks created? So I said that currency supply was one of the problems for decentralized cryptocurrencies, and new 6.25 bitcoins are created every block. So how quickly do these, what is the interblock time? How quickly are new blocks created? So in the Bitcoin protocol, it tries to achieve an interblock time of 10 minutes. But how do you do that? How can you enforce that rule? So there is something called a timestamp in each block, which is like a Unix timestamp. It just measures the number of seconds since January 1st, 1970. So each miner can put the timestamp. Before they start mining, they will just put their timestamp in the candidate block and start mining. And every 2016 blocks, this corresponds to 2 weeks worth of blocks if you assume that a block is produced every 10 minutes. So if you multiply 14 days into 24 hours into 6, that is 10 minutes per block is 6 blocks per hour. So 14 into 24 into 6 will give you 2016. So every 2016 blocks, this n bits, this corresponds to that threshold, that is recalculated. This target t, which is encoded in this n bits, is recalculated. So what is the retargeting, what is the calculation rule? So what the miner will do, all the miners will do every 2016 blocks is, they will compute the number of seconds which is taken to mine the last 2016 blocks. And the way they compute these number of seconds is, they look at the difference between the timestamps of the block at which I have to do the recalculation of the target and the 2016th block previous to that. So basically they look at the difference in the timestamp values between the current block and the 2016th block in the past, and they use that and they calculate the new threshold, this n bits. The new threshold value is, this is the formula. So what does this formula say? So suppose the number of seconds taken to mine the last 2016 blocks was exactly equal to 10 minutes. Then the numerator will be equal to this denominator. Denominator is 2016 blocks, 10 minutes per block and 60 seconds per minute. So if the number of seconds taken to mine the last 2016 blocks was exactly 10 minutes on the average, then the new threshold will be equal to the old threshold, because t sum is precisely equal to this denominator. That is 2016 blocks, 10 minutes per block and 60 seconds per minute. But suppose blocks are being mined faster. Somehow there is too much hash power in the network and blocks are being mined faster. So recall that the probability of success in a single trial is this. So as t increases, then the probability becomes larger, and t decreases, probability becomes smaller. So suppose blocks are being mined 8 minutes, every 8 minutes on the average. So that is, there is so much hash power that instead of the 10 minutes we want to target, they are being mined faster. They are being mined every 8 minutes. Then the t sum, the number of seconds taken to mine 2016 blocks, suppose it's 8 minutes on the average, it's 2016 into 8 into 60. Then the new threshold, if you plug this value in the numerator here, this first 2016 and 60 cancel and you just get 8 by 10, which is 4 by 5. So the new threshold will be smaller than the old threshold. So the probability of success will reduce, because the probability of success is proportional to the threshold. So when the recalculation of the difficulty of the mining process happens, if the blocks are being mined faster than 10 minutes, then the problem is made harder. And how do you make the problem harder? By reducing the threshold. The probability of success in a single trial reduces. But on the other hand, if the blocks are being mined too slow, there is too less hash power, and 10 minutes is not being achieved, 12 minutes is being achieved, let's say. So blocks are being mined 12 minutes on the average. Then when you plug in this number of seconds taken to mine the last 2016 blocks into the numerator here, you get 12 by 10, which is 6 by 5. So the new threshold increases. It is larger than the old threshold. Again, probability of success is proportional to the threshold, so the probability of success increases. So you are making the mining problem easier. So when the interblock time is 12 minutes, you want to make the problem easier so that it comes back to 10 minutes. And when the interblock time is 8 minutes, you want to make the problem harder so it increases to 10 minutes. So this is the way the Bitcoin network retargets the difficulty. And it happens every 2016 blocks, which is about 2 weeks. So any questions about this? So the comment was that it can be done continuously also. Yeah, it can be done, but it's just that they'll like some of the Bitcoin protocol parameters, why 2 weeks, why not 1 week, why not 1 day. So those are arbitrary parameters chosen by the creator. So there are cryptocurrencies which do targeting difficulty retargeting every block. So that has happened in later, but in Bitcoin it's just an arbitrary choice by the creator. Yeah, so the comment was that proof of work takes time, but we want to create a block every 10 minutes, right? Yeah, so it is we want to somehow control the creation of new Bitcoins. So we want to target an interblock time of 10 minutes. Okay. So if it is not 10 minutes, the protocol won't break. So it has happened that sometimes the interblock time has been many hours, because again it is a random process. So sometimes all the miners get unlucky and no new block was created. But if there no new block was created for a long time, then this T sum will become very large, and the new threshold will become larger than the old threshold, and again the mining will become easier. So it is like an adaptive changing of the threshold to target 10 minutes. Yeah. So the comment was that this is for the miners all over the world. Yeah. So the Bitcoin blockchain is a linear list. So as long as everybody looks at the same list of blocks, this calculation of the new target will be the same. Okay. So the question was that when there is a fork in the chain, some blocks become stale blocks. Those blocks are discarded. What happens to the transactions in the discarded blocks? They become invalid. So suppose I buy a painting using Bitcoin, and the painter gave the painting to me, and then my transaction became invalid. Then the Bitcoins will come back to my account, and the painting will still be with me. So that is why people wait for something called confirmations. So suppose I want to buy a high value item, then I wait for many blocks after the transaction has happened before parting with the goods. If I am a seller, I should part with my goods only after my block has received many other blocks on top of it, because the chance of a fork happening much earlier in the past is lower. It usually happens at the tip of the chain. Okay. So let's look at some actual Bitcoin blocks. So there are Bitcoin block explorers. So the blockchain itself is like a binary blob of data. But what people have built is they've built websites which are nice user interfaces where you can view blockchain data. So let me quickly show you one. Let me switch my. Okay. So this is this Blockstream is one explorer. So it is showing some blocks. So this is the height of the block. So the first block had height 0 indexing. So it starts with 0. This is the 767,355th block. So let's see what is inside. I click on that, and I don't know if let me make the font a little bigger. So it says this is the height, and this is something called 17 confirmations. So confirmation is how many new blocks have been created on top of this block. So this page is, I think, stale. So let me refresh it and go back to. So this is the latest block, I hope. Let's refresh. Yeah. So this block has only one confirmation. So which means that there is one block which has been created on top of it, but the blockchain explorer is not showing it because it is too early for that to show. What else is there? So this is the Coinbase transaction. This is an address here, and it has received 6.387 Bitcoin. Now why 6.387? 6.25 is a new Bitcoin created, and then the remaining Bitcoin is the fees which the other transactions in the block are paying that miner. So there is a transaction fees which also needs to be paid to include transactions. If there is no transaction fees, then people will spam your blockchain with a lot of junk. So that's why it's more than 6.25. I don't know if you can read it, 6.38. Okay. And then there's a bunch. So this is Coinbase, and everything else is these are regular transactions. So here it is showing that from a address which was holding 0.01 Bitcoin, 0.006 was sent to some other address. It's actually 0.018, 0.006 was sent, and 0.011 was sent to some other address. So these are the recipient address. So this is how explorers look like. So let me switch back to
hash of the previous.
Yeah, you're right. So this so the question was, what is this? So this is the difficulty of the block. This is the threshold below which the mining has to the double hash of the block header has to fall.
Sir, the hash of the previous block, where is it mentioned? It is also the block header.
Yeah, I should have repeated your previous question. The previous question was what is this 0 thing? So my answer was this is the mining difficulty, the mining threshold, and the hash previous block, so the block explorer is not showing it because it is not necessary for regular users, but this is the previous block, and here the block explorer is not showing the hash previous block because I guess, let's see, maybe it will be in the details. Yeah, so these fields we'll come back to later. Merkle root is the hash of the transactions. So the difficulty in binary is being shown here. I think if you convert it into this hexadecimal, you'll get something like this. Yeah, so the hash previous block is not being shown. So what the block explorer is doing is showing a nice height. So when I showed you the block header does not have the height of the blocks. It only has hash previous block. So the block explorer is converting into more usable information. So there are other block explorers you can see. This blockchain.com is also a popular one. So I already showed you like regular and Coinbase transactions. So this, how do we generate addresses? So anybody in the world can generate an address. It is just a public, it is derived from a private public key pair. So let's quickly generate an address at something called bitaddress.org. So this is a website where you can generate your own Bitcoin address. So a Bitcoin address is derived from a private key, and the private key needs 256 bits of randomness. So here it is saying that move your mouse around to add some extra randomness, or type some random characters into this text box. So you just move your mouse around, it is generating the randomness in your, or you can type something and it will generate a private key. And then once it generates that private key, it's at 69, 74%, 89, 91. Okay. So it has reached 100% of randomness, so it will generate this. So this is the Bitcoin address. This is a public address, and this is the private key. So you should never, if you generate an address, you should never reveal this part which is labeled as secret. This is the. So anybody in the world can generate an address. So there is no cost of generating an address. So you just suppose I am a vendor, I accept Bitcoin as payment. I just generate an address, make sure I hide the secret key, and when somebody asks me, okay, what is your address? I want to pay you in Bitcoin. You share the QR code, and it will just work. So then there is also something called like a brain wallet. So brain wallet is that you can generate you can take some phrase, and you can just generate a private key from that. So why not use randomness? So sometimes suppose I am a refugee and I am being forced to flee from my country and I can't take my bank account with me, I am going to a different country. Then maybe what I do is that I take the money in my bank account, I convert it into Bitcoin and I store it in a address which is generated from a brain wallet. A brain wallet is you take a phrase which you can remember easily and you hash that to generate the address. So let me show that. And so why not carry something like this? Let me transition if I'll forget. Why not carry something like this? But suppose I'm searched at the border when I'm going to a new country, I may lose my money. If somebody is, the security or the guards at the border are savvy enough, they may figure out it's a private key and they may steal my Bitcoin. So here it is complaining about some address, but let me. So here I could type something like how much wood can a woodchuck chuck if a woodchuck could chuck wood. And let me toggle this. So then this address has been using that phrase was hashed and a private key was generated and I am generating an address. So now the only thing I need to do is just store this address. I just remember this phrase and I can derive my private key from that. But brain wallets are considered very unsafe, so you should never have real money in brain wallets. This is just for demonstration that sometimes you can just carry your bank with you in the sense that Bitcoin is a decentralized network. It is accepted in many countries. So if you are in a situation, typically in India we don't have such situations, but in a situation where you have to carry your assets with you, it's like a very useful thing. So what happened is that people searched for a lot of passphrases on the Bitcoin blockchain, and they found that many of the passphrases were actually cracked. So I think I made some mistake here, but let me use another phrase you can't see what you can see what I'm doing, so that but it will not get recorded, so that's fine. Okay, so this is the address. So let's see in the let's see, I'll copy this address and I will put it in the blockchain explorer. And if you see that, so some transactions have happened in this, and some of these transactions are very recent. This one is 2 weeks is 2016 blocks. So this is like less than about 1.5 weeks ago, 1445 confirmations. So somebody has taken money from this address, but who sent money to this address? This address was generated from this passphrase which is already cracked. Many people had figured out that this passphrase, how much wood can a woodchuck chuck, was used to generate this address. But in spite of that, somebody has sent money to that, and that money has been, it is being swept by some bots. This BC1 address has been sweeping money which is coming out of these addresses. Coming up to this address is 1GGJ address. So brain wallets, the main takeaway is that brain wallets are not secure, but they can be convenient if you're sure of nobody being able to guess what that.
Sir, the people who are operating brain wallet, they can see the address which is being generated.
Yeah. So the question was that the people who are operating the brain wallet, they can see. So yeah. So you can download this web page and you can run it in offline mode. And they even they actually suggest that you do that. And the algorithm for generating brain wallets is not secret. So you can write your own Python code and just run on your own computer and generate a brain wallet also, in the sense that.
How it will go onto the blockchain token?
So the question was that how will the address go onto the blockchain? So the first time an address appears on the blockchain is when somebody sends Bitcoin to it. So there is no registration process. So suppose now I create a new address and I buy some Bitcoin, or I give somebody some money and say that okay, send to this address. When he sends Bitcoin to that address, then it gets recorded that this address has coins.
So anybody can claim from that address, right?
The comment was anybody can claim from the address. Only the people who with the private key can claim from the address. So you only put the address is derived from the private key. I'll show the process a little later. It is derived from the public key of the brain wallet, and then only people with the private key can spend from it. So another thing we said about Bitcoin was that the currency supply. So how do you, again, decentralized system, how do you limit the supply? So the main way that it is limited is that the number of Bitcoins per block is fixed, and it has a specific way of specific schedule, and the interblock time is also somewhat adaptive to 10 minutes. So the initial block subsidy when Bitcoin launched was 50 Bitcoins per block, and then every 4 years, which is about 210,000 blocks, the block subsidy, that is the reward which goes to the miners, it halves. So it became 25 Bitcoin per block in 2012, 12.5 in 2016, and 6.25 in 2020. So 2 years from now, in 2024, it will become 3.125 and so on. So the total Bitcoin supply is approximately 21 million. So it looks like this. So January 2009, if this the y-axis is number of Bitcoins mined. So 21 million is somewhere here. This is 20 million actually. So it's currently around 19 million Bitcoins have already been mined, and the last Bitcoin will be mined in 2140, which is quite a few years from now. And then after that, the only reward a miner will get is only the transaction fees, because after that no new Bitcoin will be created in the Bitcoin protocol. So that is the Bitcoin supply. So the creator of Bitcoin, he had issues with inflation, in the sense that government's printing money to bail out banks and so on. So so in his own the protocol he created, he wanted this amount of money to be fixed. So that's why this algorithm which he has put there. Okay, so many times when people hear about blockchain, they said immutable database. So I want to maybe dispel some myths about that. Blockchain does not automatically mean immutable. you can always change it, but you need to meet some conditions. So suppose Alice wants to modify a block Bn. Okay. Suppose Alice sold a painting or bought a painting from a famous painter, maybe she's paid 1 Bitcoin for it, and she feels that if she can delete that transaction where she paid 1 Bitcoin, she already has the painting. If she can delete the transaction, then the spending history will be gone and the Bitcoin will be back in her address. So I'll explain why it is so, why it comes back to her address. But suppose she wants to modify some block at height n, let's say block Bn. Now if she modifies the block which is on a local hard disk, it does not mean anything. So if you modify the local copy of your blockchain, it does not mean anything. What you need to do is you need to modify all the blocks all over the world. But how can you get access to all the, I should say that again, you want to modify the blockchains, the copy of the Bitcoin blockchain all over the world, but you don't have access to the copies of the Bitcoin blockchain because they are behind passwords and so on. So the way you can do it is that if Alice can create a branch of the Bitcoin blockchain which is more difficult to produce than the branch which has Bn, then all the nodes in the network will switch to this branch. So Alice wants to modify this block Bn. So she creates a modified block An, and then she starts mining on top of that. And if she can somehow create a chain which is, or a fork which is longer than the regular chain, then the Bitcoin protocol says that the longest chain is the valid chain, or the chain which is the most difficult to produce is the valid chain. So all the nodes in the network will switch to this, and then this Bn would have been modified to An. Now what will happen is that in addition to modifying this, all the Coinbase transactions, Alice can say that pay me the Bitcoin which is being created in all these blocks. So Alice can also gain all those Bitcoins which were earlier in the hands of the miners who created these blocks. But the thing is, she needs to mine blocks faster than the rest of the miners, and it is possible if she controls 50% or more of the network hash rate. But what does it mean to control 50% or more of the network hash rate? So the current network hash rate is 250 exahashes per second. So that is 250 10 times 10 raised to 18 hash. Each hash is a double SHA-256 hash. So this is the current Bitcoin network hash rate all over the world. Now one mining unit costs about $2,000. It gives you 100 terahashes. Terahashes is 10 to the 12. So if you want to control 50% of the hash rate, you have to control about $2.5 billion worth of hardware. And I'm not taking into account the operating cost of the air conditioning and all the labor costs, and also the real estate cost of actually housing all that equipment. And so this is only the cost of buying these mining units which will let you control half of this 125 exahashes. That itself amounts to controlling $2.5 billion worth of hardware. If she can do this, if she controls 50% of the hash rate, she can rewrite the history of the Bitcoin blockchain. So a blockchain by itself is not immutable. So it's not like immutable ledger. Once you put on the blockchain, it's not. You can change the history, but it costs a lot of money. And you should be ready to burn this money, because if somebody were to rewrite the history of the blockchain, of the Bitcoin blockchain, the value of Bitcoin will go down. Why will it go down? Suppose I have my life savings in Bitcoin. If somebody is going to change the history, then my life savings may disappear. Then I will not buy Bitcoin. I will not invest in Bitcoin. So the value of Bitcoin comes from the fact that it does not change its history. But if somebody were to change this history, its value will go down in the eyes of the public. Then so whoever wants to rewrite this, even if they have $2.5 billion, they should be ready to burn this money, in the sense that whatever they get by changing the Bitcoin blockchain, that should be worth more than $2.5 billion. So tamper resistance is not tamper resistance of blockchains is a myth. It is not that you can change, but it is hard. So that is the issue. So what is the hash rate? So how is the hash? Because 250 exahashes, will it change? Will it become lower, higher? So this is the history of the hash rate in the last 3 years. So it was at 100 exahashes, and I think usually the hash rate is correlated with the market price of Bitcoin. So I think this was some kind of Bitcoin crash. So I think it went from maybe $40,000 a Bitcoin to 20,000. So this corresponds to that. Then it has been rising. Again, there's been some recent market crash. So again, it has been falling. So the trend has been it is going up, but it can go down at any time, we do not know, there is no guarantee. So the key takeaways are Bitcoin's blockchain prevents double spending and tampering. It is secure only if nobody controls 50% or more of the network hash rate, and mining difficulty is adjusted to regulate coin supply. So the coin supply is how many bitcoins per block, what is the interblock time. So you keep changing the mining difficulty to target an interblock time of 10 minutes, and the miners are incentivized by the block reward. So they want to keep mining because they get that bitcoins per block, 6.25 currently, and the block subsidy, it becomes half every 4 years to cap the total coin supply to about 21 million. So we have some time. So the thing with cryptocurrency networks is that there is a mainnet and a testnet, and the testnet is typically used for development. Suppose I am building some Bitcoin product or I want to do some testing, then if I do on mainnet I may lose my bitcoins which are valuable. So typically there is one or more testnets where you can do testnet transactions. So there are a bunch of testnet explorers. You can go to these explorers and try them, and you can also create a testnet address. So this kimbat.github.io BTC address generator, but at the end don't forget to put this question mark testnet. So you will get you can generate a testnet address, and you can suppose I want to do some testing, where do I get the coins from? So there are websites called faucets. So Bitcoin has them, Ethereum has them. Faucets are, what do faucets are like? They're wash basins, they drip, usually faucets leak. So these websites will drip bitcoins for you, so to play around. So this Bitcoin faucet, this is not a L, this is a 1, uo1.net. This will, you can go to that, put in your testnet address which you generated, and you can get some testnet coins. Then if you have Android, I couldn't find a wallet, testnet wallet on iOS, but if you have Android you can install this mycelium testnet wallet, and you can put your testnet coins in that, and you can do transactions with each other. So let me show you the faucet part, because I can't show you the Android in this, but let's go to the BTC generator, skimbat.github.io. So then it says move your mouse around for randomness. I'll just skip this part. So here is a new address. So the address starts with T for testnet. So I'll just copy this, and should typically not share this. This is a private key. But the testnet coins are not worth anything, so it's fine. Then I need to go to a faucet. So I bookmarked it. So I go to the testnet faucet. So bitcoin faucet.uo1.net. So the current wallet balance is 340 bitcoins, and you can get up to 0.00006 bitcoin. So I paste my address here, and I say, okay, let me take the maximum. Send testnet coins. Okay. So it said 0.0006 coins sent to this address. Don't forget to send the testnet coins back when you're done with them. That's okay, we don't need to. So, but where do I see this transaction? So let's go to the block explorer again, but this time I will affix the blockstream.info, but I'll just say testnet at the end. So it's a testnet. So like where is my transaction? So where is that address which has my transaction? So I copy paste that address again, and it says that so far the Bitcoin has not been received here, because remember it's like it takes about 10 minutes, right? So right now this address does not have any history on the testnet blockchain because it has not been received yet, but let's just refresh. So if you see, there is a total transaction count, it's showing 1 now, and unconfirmed transaction count. So what is an unconfirmed transaction? So a confirmed transaction is a transaction which is included in a block. Unconfirmed is that it has been received by the network. So the network has something called the mem pool, the memory pool of transactions. So this transaction which the faucet has sent the transaction to the network, it is floating around, some miner has to pick it up and mine it. So it's still an unconfirmed transaction, and it is receiving 0.00006 test Bitcoin. So let me refresh this again. It's still unconfirmed. Oh, there is the transaction details are here. So remember we saw that testnet had 340 Bitcoin. So out of that it has sent 0.0001 Bitcoin. So if you keep refreshing this, then eventually it will confirm. and it will show up, but it's okay, you can try that. Let me bring the slide back so you can try it on your own. Okay, so that's all I had, some references. This is a set of notes on Bitcoin which I have on my website. It has more details than I have covered. I'll be covering some more details in the next session. And also these are the charts from which I took the different Bitcoin supply and hash rate data. And Bitcoin mining rigs, you can check this website, shop.bitmain.com. It has different kinds of Bitcoin mining rigs. So I'll leave this slide on, so if you want to try your faucet addresses, but I can take questions if there are any. Yeah, so the question was on Bitcoin market value, like how is the market value of Bitcoin determined? Again, same supply and demand. So people see it as an asset speculation, they want to speculate on the rise of the asset. And
then why is it so volatile?
I'm not the right person to answer the volatility. So the question was, why is it volatile? I have actually no clue. I'm not an economist. It is volatile because people's confidence on Bitcoin is also volatile. They may think it will go to zero at any time. The price goes up, there's a lot of fear of missing out, and people buy. The price goes up even further. When it starts crashing, the true believers stick to it and the other people start selling, so it crashes. So people's beliefs are also volatile, and it is mainly it's an asset which maybe people, by people I mean even funds who are trying to make money off stocks, and I think they're called hedge funds. They also allocate some amount to Bitcoin, and I have no clue why it is so volatile. So any other non-market questions? Okay, so the question was that at which memory location the address is stored, and how will, if we generate an address offline, how will the Bitcoin protocol know that this memory location has to be written with the balance or something. So the answer to that question is that so I will generate an address, and like right now I went to the faucet, testnet faucet, and said send me some Bitcoin. So it sent some Bitcoin to me. So what does it mean to send a Bitcoin? So the faucet sent a transaction which is eventually going to be included in a block. So when the block has a transaction which says that some coins have been transferred to this address, at that point that address has gained some coins. So the existence of a transaction which has an address as a destination is proof that that address has coins. So the wallet software will just read all the transactions and see that let's collect all the balances across all blocks where this address has been the destination of some coins. That will be the total wallet balance.
But
okay, so the question was that how will the Bitcoin faucet know that the address was not used? So the thing is, each address is generated from 256 bits of randomness. So imagine flipping a coin 256 times. You flip 256 times, I flip 256 times. It's very unlikely that the sequence of flips will be the same. It's almost like negligible probability. So there is very less chance of address collision. But if by mistake, let's say you used a brain wallet and you generated the same address, then the other person who has a private key can also spend your coins. So there is no association of a real world entity with an address. Whoever owns the private key can spend. So if there is address collision, then basically you have shared ownership. They can steal your money.
Some Bitcoin there, he or she can spend it.
Yeah. So the question was that some of the common phrases used to generate Bitcoin brain wallets, anybody in the world can try and find those private keys. So that has already happened in 2015. So there was a researcher who wrote a very efficient code to generate a lot of addresses and check for their existence in the Bitcoin blockchain. And since then, people always advise, the general advice is don't use brain wallets. But sometimes people may still use it because they can't remember a 256 bit or a 64 hexadecimal private key. It's difficult to remember. So in general, you should not use brain wallets. Just an illustration of how you could generate addresses using randomness or using some phrase and do it. Okay, any other questions? So let me repeat your question. In spite of inflation, what is fixed?
The value of blockchain is fixed, you told.
The value of blockchain.
Money or transaction fees of what the miner will get the particular amount of.
Okay, so you want to, maybe your question is about the total currency supply is fixed to 21 million. Is that? So the value, so the Bitcoin protocol has no, it does not care about the market price. So there is no price information in the Bitcoin protocol. So it is only that 6.25 Bitcoins get created every block, Now what is the price of that? The protocol is oblivious to that. It does not care about that part. The transaction fees may vary depending on the price of Bitcoin, but the transaction fees themselves are denominated in Bitcoin itself, and it's a per byte transaction fees. So the length of the transaction determines the cost of the transaction. If you have a very long, like the size in bytes is long, then you have to pay more fees. So transaction fees is not like a percentage of the value you send. Suppose I'm sending $1 million, it is not a percentage of that. It is always, the fees is determined by the length of the transaction. Okay. Oh, yeah. So the question was that if the number of bitcoins is fixed and the number of then the number of blocks should be fixed, but I said that it halves every 4 years, right? So the 6.25 will become 3.125. So geometrically decreasing, it's a geometric sum. So that's why it is fixed to 21 million. Okay. So if there are no other questions, I think we can break. Okay. Thank you.